In this video, I will explain how to derive the 7 short-run cost functions when you are given a Cobb-Douglas production function. So let's jump into an example. This says, a firm has the following production function. Q, the quantity produced, is equal to L to the 2/3 times K to the 1/3, where L represents the units of labor and K represents the units of capital. Assume that W, the rate of labor, is $2, R, the rate of capital, is $1, and K, the units of capital, is 1. Now, based on this information, we can find all 7 short-run cost functions right here. Now, before we start finding these functions, notice that we're only missing one value, and that is L, which is the units of labor. So before we get started, let's solve for L. So notice that we said K would be equal to 1, so we're using 1 unit of capital. So if we plug in a 1 right here in this equation, 1 to the 1/3, 1 to any power is just 1. So really this whole quantity is 1. So to solve for L in this equation, all we have to write is L to the 2/3 is equal to Q. So to solve for L, to get L by itself, we can raise this whole expression to the 3/2 power. Because 3/2 is the reciprocal of 2/3. So when we multiply 2/3 by 3/2, we just end up with 1. So L to the first power, that's just L. So on this right-hand side, we also need to raise Q to the 3/2 power. So we'll find that L is equal to Q to the 3/2. So we're going to use this value for L when we're finding these short-run cost functions. So I'll go ahead and write that right here. Okay, so let's start by finding the total cost function. So the total cost, I'll abbreviate as TC, that's simply equal to the fixed costs plus the variable costs. So in the short run, we say that our capital is a fixed cost. And the total cost of our capital is simply going to be the rate of the capital R times the units of capital K. So that's just going to be R times K. And then to that we add our variable costs. These are going to be our costs associated with labor. So the total cost of our labor is going to be the rate of labor, which we're told is W is $2, times the units of labor, which is L. So we'll just have W times L. So if we fill in the values that we know, R is equal to 1 and K is also equal to 1. So we'll have 1 times 1 plus W is equal to 2. And we just solved for L right here, which is Q to the 3/2. So let's write that. So our final total cost function is simply going to be 1 times 1 is 1, plus we get 2Q to the 3/2. So this is our total cost function. So this tells us the total cost for the firm based on the quantity of goods that they decide to produce, so based on Q. Okay, now let's find our fixed cost. So let's abbreviate that as FC for fixed cost. Earlier we said that's just going to be the cost of capital. So in the short run, we're assuming that capital is a fixed cost. So it's simply R, the rate of capital, times K, the units of capital. So R times K, which again, we already saw is 1 times 1, which is just 1. So our fixed costs in the short run are just 1, in this case $1. Now our variable cost, we said that would be the cost associated with labor, which is simply W, the rate of labor, times L, the units of labor. So we'll say the variable cost is just W times L. So we know that's just 2 times, for L, we found that to be equal to Q to the 3/2. So we have Q to the 3/2 power. So that is our variable cost. And we'll notice that our fixed cost plus our variable cost, that's equal to our total cost function. So that's good. Next, we can find our average total cost. So let's abbreviate that as ATC, average total cost. That's simply going to be the total cost divided by the quantity produced. So we already found our total cost function. So if we take that whole function and divide it by Q, let's see what we get. So when we have this expression, we can divide both terms in the numerator by Q. So we get 1 divided by Q, plus we'll have 2Q to the 3/2 divided by Q. Now here we can imagine this is Q to the first power. So we can cancel out one full Q in this numerator with this Q, and we'll be left with Q to the 1/2 in the numerator. So our final average total cost function will be 1 over Q, plus we'll have 2 times Q to the 1/2 power. So that's our average total cost function. Then we can find our average fixed cost function. So let's abbreviate that as AFC. It's simply equal to the fixed cost divided by the quantity. So earlier we saw our fixed cost is 1. So our average fixed cost is just 1 divided by Q. And we can leave it like that. Next, we can find our average variable cost. So let's abbreviate that AVC. That's equal to our variable cost divided by quantity. So we saw that our variable cost from earlier was 2 times q to the 3 halves. So let's write 2q to the 3 halves divided by q. So if we imagine this is q to the first power, so we can cancel out this q and subtract 1 from this exponent right here. So this will become a 1/2. So our average variable cost is going to be 2 times q to the 1/2. And lastly, we can find our marginal cost function. So let's write MC, let's squeeze that in down here. That's going to be the derivative of the total cost function with respect to q. So if we consider our total cost function that we found up here, the derivative of this function with respect to q, this 1 would become nothing, and the derivative of this term, we would take the exponent and multiply it by the coefficient. So 3 halves times 2, that's equal to 3, and then we reduce the exponent by 1. So this would become 1/2. So we have 3q to the 1/2. So that is our marginal cost function. So that is how you can find the 7 short-run cost functions when you are given a Cobb-Douglas production function.